Recall the Swiss data set. So here's the first couple of variables, and I want y to be the fertility variable, and I'm going to let x be everything except the fertility variable. I'm going to define x1. I want an intercept in there, so there now x has an intercept. And I want x, make sure it's a matrix. And then let me let x1 be equal to x columns 1 to 3, and let me let x2 be equal to x columns 4 to 6, the final 4 columns. So first of all, let's look at the solve. There's the estimates, the beta that I get if I numerically solve the equation, the normal equations. And now let's show that these are equivalent if I take the residual, having removed x1 from everything, and then take x2. So if I do solve t of x1 star x1 and t of x1 star y, if I do that, that's going to give me my regression estimates for just x1 fitted as the predictor and y as the outcome. And so I want those times x1, I want the residual, so I want y minus x1 times that. Oops, and I want to solve that, set that to a variable. Let's call that ey. The residual of y, having removed x1, is called ey. Now x2, right, I want to be the residual of x2 having regressed out x1. So that's going to be x1, and then okay, so it's x, let me just double check. So it's x2 minus x1 times x1 transpose x1 inverse, x1 transpose times the, what I'm treating as the outcome in this case is x2. Okay, so now if I then, so let's take dim ex2. Okay, that's the right dimension. And so now my claim is if I take the regression with ey as an outcome and ex2 as a predictor, I should get the same regression estimates that if I did the full multivariable regression with x1 and x2 included in the model. Okay, so now I want to do solve ex2, 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 ey, and then forgot my transpose there. Okay, and then I get these three coefficients. Now let me compare that back to when I got y by itself. Okay, and notice they're identical: negative 0.87, negative 0.87, 0.1, 1.07. And what this is highlighting is that if I take my x2 column and if I take my x2 matrix and I regress x1 out of every column, and if I take my y vector and I regress x1 out of it, and then I do regression treating those sets of residuals as the outcome and predictor respectively, then I get the same answer if I just fit the whole thing. And that really highlights how it is that multivariable regression is doing adjustment. The coefficients for x2 are adjusted in the sense that the linear association with x1 has been removed from everything before considering x2. Okay, and conversely, the same thing holds true for x1. The coefficients for x1 are adjusted for x2 in the sense that x2 has been removed from everything before you consider the regression of x2 on y. Okay, so that, to me, this really highlights in what sense regression is doing adjustment.